Welcome to Module 11.1, Solving System of Linear Equation by Graphing. So in this lecture video, I'm going to actually show you how to do this, solving the system linear equation by graphing. So here are a type of procedure. This is what we're going to do. So we're going to graph both linear equation on the same set of axes. Then we're going to observe the point of intersection if there is one. So like I mentioned in a previous video, when we draw two lines, they can intersect at one point, they can parallel, or they can be exactly the same line. That means they have infinite number of solutions. So if the slopes of the two lines are different, then the line intersect at one point and only at one point. The system have a single point as its solution. If the lines have the same slope, if the line has the same slope and different y-intercept, then they are parallel lines. That means they have no solutions. If the lines are the same line, then all points on the line constitute a solution. Then there are an infinite number of solutions. Okay, then we can also check it as well. Check it against its original equation. So this is kind of strange. When we do this on the computer using Hawk's learning, from module 10, you notice when you type in your slope in the y-intercept, the computer actually graph the line for you, or you can enter 2 points and the computer graph the line for you. But since I'm doing this, not using the Hawk's learning right now, so I'm gonna show you how to draw the two line by hand. Okay, so just remember, when you do these type of problem on the Hawk's learning, once you key in the slope and the y-intercept, they will automatically show you what the two lines are, and then they're gonna show you the point of intersection. So here, I got to actually, figure it out, the point intersection, after I graph. All right, so just bear with me for a moment. So let's draw the first line. Okay, let's draw the first line. So what we want to do is write our equation of the line in slope-intercept form. Right now they are in standard form. So to get them into slope-intercept form, I got to solve for y. So my first line, 7x plus 7y equal to -14. All right. Before, this is a very good tactic. If you look at these coefficient and constant term, they're all divisible by 7. So if I divide every term by 7 initially, then I will get x plus y equal to -2. All right, now I'm going to get my y by itself. Since my variable term is positive, I'm going to let it stay. So move the x over. So my y is equal to -x minus 2. So what do I key in here? On the first line, I will actually key in -1x plus -2. All right. But now I got to draw this line by hand. So by looking at the slope-intercept form, my slope m, I'm going to do it red real quick. My m is -1. Slope is -1. -1 means -1 over 1. That means we will go down 1, then to the right 1. All right, my y-intercept, 0, -2. So from module 10, you can recall we're going to plot the y-intercept first and use the slope to go to the next point, which is down 1 to the right 1. Okay, let me do a couple more. Down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. Now if I need to backtrack, that means go opposite way of what my slope says. That means I will go up 1 to the left 1, up 1 to the left 1, up 1 to the left 1. So I'm just gonna come up with several points real quick. And then I'm going to work on the second equation and see if I can trace my way to the point intersection. Negative 8x plus 4y, negative 8x plus 4y equal to, excuse me, let me see, 28. All right, again, the negative 8, the 4, the 28, is it 28 or negative 28? 28. All right, the two coefficient of constant term is divisible by 4. So I'm going to go ahead and do that. Get my coefficient small. Good technique. Good technique. So that's negative 2x plus y equal to 7. So quickly I see my variable term is positive y. I'm going to let it stay on the left side. I'm going to move my negative 2x over. So I get y equal positive 2x plus 7. All right, so in the second line, 2x plus 7, that's what I key in. So the computer should draw a line for you. But here, let me do this real quick by hand. My slope m is 2. 2 means 2 over 1. That means I will need to go up 2 to the right 1 from my y-intercept. 0, 7. So here I'm going to plot 0, 7. That will be right here. All right, follow my slope. Up 2 to the right 1. Up 2 to the right 1. Ooh. If I keep going, I'll go outside of my screen. So it looked like my blue line, my second line is going this direction, up the hill, positive slope. So I need to go back down towards this direction in order to see where they intersect. So let's backtrack this slope. From the y-intercept, down 2 to the left 1. Down 2 to the left 1. Down 1, 2 to the left 1, 1. Bingo, right there. That is the point of intersection. So once I find the point intersection, or once you see the point intersection on the computer, then you will have to select one solution. You got to click right here and write down the point intersection. So this point intersection is negative 1, negative 2, negative 3, up 1. So that's negative 3, comma, negative 3, comma, positive 1. So this point, okay, this point is the solution to the entire system because only negative 3 for x, positive 1 for y will satisfy the entire system. All right. Let's try another one. I'm going to copy this down so I can see this a little bit better. Ooh, that's a little bit too loud. Excuse me. Let me turn down my volume here. I'm going to bring this down a little bit. All right. So now I'm going to get y by itself. So before I do that, this is my first line, okay? This is my second line. My first line, look like I can divide every term by 3. So that will give me negative x plus y equal to negative 10. So I'm going to quickly move my negative x over since my variable term is positive y. So I'm going to let it stay there. So that gives me y equals 1x minus 10. So my slope m is 1 over 1, my y-intercept, 0, comma, negative 10. All right. So I'm going to write this down for my reference for the graph. Here, what you key in is 1x plus negative 10. All right, 0, negative 10 is way down here. Slope is positive, so up 1 to the right 1. So I'm going to do a little bit more, okay? Up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. All right, let's work on the second one. It looks like the second one, ooh, there's a y right there. Looks like the second one, every term is divisible by 2. So for my second one, if I divide every term by 2, that gives me x plus y divide every term by 2 equal to 4. All right, my variable term y is positive, let it stay. So I'm going to move my x over to the other side so I can write them in slope-intercept form. So that's y equals negative x plus 4. So my slope m is negative 1 means over 1, down 1 to the right 1. My slope, my y-intercept, 0, 4. So what do I key in here in the second one? Y equals negative 1x plus 4. So once you type those in, they'll draw two lines. You can see whether they intersect. You can see where they're intersecting at. But here I gotta do this by hand. 0, 4 right here. Down 1 to the right 1. Oof, that's a long way to see. They're intersecting about somewhere right here. So I'm gonna keep going. Down 1 to the right 1, down 1 to the right, down 1 to the right, oh, down 1 to the right, down 1 to the right, down 1 to the right here, because the red one is up 1 to the right 1. So this is the point of intersection. All right, so they do intersecting at one point, which is right here, which is 7, negative 3. 7, negative 3. Okay, that'll be right here. All right, that's my solution. All right, so let me go back up here real quick. So here we wrote, okay, I'll give you two examples where they do have a single point as its solution. So let's take a look at what happens when we run into no solution and infinite number solution, okay? So most of the time when we see these problems, it's not very obvious what the answer is. So you kind of still have to work it out a little bit to know what's going on. So let me copy that, bring it down here. All right, look at my first line. All three terms is divisible by 2, so I get x plus y equal to negative 20, negative 10, excuse me. All right, since my variable term is positive, let it stay. So let's move my x over, and I get y equal negative x minus 10. So here I key in negative 1x plus negative 10. All right, I'm going to go ahead and write down my slope. Negative 1 means negative 1 over 1. Y-intercept, zero comma negative 10. All right, so that's way down here. Let me go ahead and get a couple points started. Down 1 to the right 1. If I down 1 to the right 1, I'm outside of my graph. So let's backtrack. Up 1 to the left 1. Up 1 to the left 1. Up 1 to the left. Up 1 to the left 1. Up 1 to the left 1. Okay. Alrighty. Okay, let's see what I got here. Second one. Negative 7x plus y equal to 6. So my variable term is positive. Move my negative 7 over. So that's y equal to 7x plus 6. So I guess I'm not gonna run into the no solution or infinite number solution because I notice my slopes are different. Negative 1 for slope, 7 for slope. So when my slopes are different, that means these two lines will intersecting somewhere. Is when my slopes are the same, then I'm gonna start running into no solutions or infinite number solutions. Alright, so let me go ahead and get this thing going here. Y-intercept is 0, 6. That's way up here. So my slope is up 7 to the right 1. So if I go out 7, I'm going to go outside here. So let's backtrack down 7 instead. Let's backtrack down 7. 1, 2, 3, 4, 5, 6, 7 to the left one. Did I count it right? 1, 2, 3, 4, 5, 6, 7. Yep. Do it again. 1, 2, 3, 4, 5, 6, 7 to the left one. Oh, right here. This is where they're going to intersect. Down 7 to the left one. Voila. And what's that point intersection? -2, -8. Choose this one. -2, -8. All right, let me just go ahead and draw this while I'm at it. So this is my second line. Sorry, I didn't quite connect them. Let me kind of fix it a little bit. There you go. And the other one, let me go ahead and connect them with this. Like it nice and pretty. All right. All right, so this one has one solution. Okay, so now this one, I think here we go. I can almost see it. I will show it to you. So you see the first one, the first equation, or the first line, every term is divisible by 3. So if I do that, divide every term by 3, I get -x plus y equal to -3. Since my variable term is positive, I'm going to let it stay on the left side with the -x over. So now it will be y equal to 1x minus 3. So slope is 1x, y-intercept -3. All right, second line. You see the second line, every term is divisible by 4. So if I do that, if I divide every term by 4, that's -x plus y equal to -3. Do you see it? This is exactly the same as up here. So if I get x by itself, excuse me, if I get y by itself, this come over, the variable term stay, -x move over, then I will still have a y equals positive 1x minus 3. So what do you think? You should see what? You should see exactly the same line. That means there's only one line here. Because both lines, the y-intercept is at -3, and the slope is up 1 to the right 1. So you should only see one line. And it's kind of weird why it's only one line, because these two lines are exactly the same. So they're on top of one another. So that means they're intersecting infinite number of times. So that will be infinite number solution. All right. Excuse me. All right. These I didn't put any graph right here because I want to train you how to do this just by visually looking at it. Okay. Once I get y by itself, see if we can determine what's going on. Okay. So the first line, get y by itself. All right, since my y is already positive, I'm going to let it stay there. So I'm going to move the 4x over. So this problem, I cannot divide every term by a particular coefficient or common factor because this is 4, 1, 21. So what I got myself here is y equals -4x plus 21. -4x plus 21. So this problem, I really cannot graph because normally what you notice is the graph that the Hawks Learning provides is only from -10 to +10 for the x direction and the y direction. So in this problem, I really cannot graph by hand. All right, second one, do you see the second line? 8 to 24, this L3 term is divisible by 2. So if I do that, divided by 2, divided by 2, divided by 2, then that would be 4x plus y equal to 12. So if I want to get y by itself, you see variable term is positive. That means I can move the x to the right side. Then I should have y equal negative 4x plus 12. So what you're noticing here is the slope are the same, but the y-intercept are different. In that case, let me go back up, sorry. Same slope, different y-intercept. That means the two lines are what? Parallel. So I have no solution. Okay, that's how we do this. All right, I want to take a moment here, kind of show you how to deal with um, dealing with a fraction. Okay, so in module 9, um, we we talked about clearing the fraction by multiply every term by the least common denominator. Now that technique come in handy now. All right, because I don't really want to more complicate this even more. Now we can still, if you know how the process work, you can still use a calculator, okay, to do this. You can still use a calculator to kind of help you a little bit. But I want to show you this technique. If I want to clear the fraction, so that will be LCD between 3 and 3 is going to be 3. So I'm going to multiply every term by 3. I'm showing you this because in other sections of Module 11, we will do this quite often. Not dealing with fraction, but dealing with some of the type of numbers. All right. 3 times 1/3, the top 3, bottom 3 cancel out. That is 1x. I'll put it right here. All right. 3 times negative 4y, negative 12y, equals top 3, bottom 3 cancels out. That would just be 100. All right. Now to get y by itself, since my variable term this time is negative, what I can do is move this term to the right. At the same time, move the positive 11 back to the left side. So I get 12y. Negative 12y come over, become positive. On the left side, x still x, positive 100 come over, becomes negative. All right, divide every term by the coefficient 12. My answer was 100 over 12. I don't know. Convert to a fraction. 25 over 3. So this is 1 over 12. X minus 25 over, what was it, 25 over 3 equal to y. All right, so in here I wrote 1 over 12 plus negative 25 over 3. Please key in the negative. If you don't, the computer sees as a positive again, so that will actually throw your answer off. All right, the second one, LCD. Again, clear the fraction. LCD is only a 2. So multiply every term by 2. That means I will get top 2, bottom 2 cancels out. So that just leave me with 7x minus 6y, right? Negative 3 times 2 equals, on 38 times 2, 76. To get my variable term by itself, since my variable term is negative, what I can do is move over to the other side. That means 76 come over to the left side. So now negative 6y come over, become positive 6y. 7x is still 7x. 76 come over, becomes negative. All right, divide every term by 6. Ooh, this one's nasty. Let me make sure everything is right. Oops, sorry. So y is equal to 7 over 6x minus 76 over 6. So let me check my numbers real quick, because I want this problem, I thought this problem is only a certain way. That's x minus 12 equal to 100. Yup. Ooh. Okay, so I believe this problem, once you key it in both, you should be able to see the point of intersection. I don't know what it is. I can't key in. I can't graph all this by hand, but you should be able to see the point of intersection. Negative 76 over 6. Because normally the computer keep, when they draw the two lines, they will make sure you see where they're intersecting at. All right. So I guess this problem is not what I thought it was. I thought it was going to be a certain answer, but it turns out the slopes are very different. Because I don't think I make any mistake here. That's 7 over 2. So that's 7, negative 6, 76. So yeah. All right. So I just want to show y'all how to handle this one in particular, how you can handle dealing with fraction by clear every term. Okay, multiply every term by the LCD to clear out the fraction. All right, so in this lecture video, we talk about how to solve system with linear equation by graphing. Okay, so I did demonstrate how to do this by hand on the graphing paper, but normally when students key in these slope and y-intercept, the computer graph the line for you. Alrighty, that will conclude this lecture video. Thank you for watching.